So we are talking about battery using in marine ships and industries. So types of battery should be used on board ships. So first kind of question will come like this: battery. What is battery? Battery may be storage of charge inside the plates to use the consumption of the loads in various machineries. So laws regulations for battery. In so laws regulations, chapter 2, part 1, electrical installation inside onboard ships. We are using various machineries and various machineries which consuming the power the batteries installed inside the ship. A properly maintained battery will instantly supply electric power when required. The feature makes a battery a key element in provision of essential and emergency power supply on board ship. Mainly, battery will supply instant supply to the machineries when required in case of an emergency power supply if machinery will be affected with emergency situations. From emergency switchboard, there is a connection between batteries and main power supply. First of all, from the emergency switchboard, the one supply goes through the emergency supply 440 volt or 220 volt through transformer. We are providing to the emergency switchboard. Then emergency switchboard through distribution switchboards and various protection system supply goes to the essential services in case of any emergency situation should be happen. So power supply should be given to the radio equipments, emergency fire pump, and the fire pumps of capacity 25 meter cube per hour for general cargo ships, and for passenger ships we are using 15 to 20 meter cube per hour. And we are using in steering gear system 440 volt supply given to the steering system in case of emergency situation should be happen inside onboard ships. And navigation lights and equipments throughout the deck. Aft, aft ships, aft mast, forward and stern part. Red light should be on the port side and green light green light should be indicating on the starboard side. Now we're talking about the mast. Mast side should be indicated with white light throughout the ship, and side light should be given for the indication for the another ships due to any other collisions, or navigation route should be provided. So yes, and that's the main and interesting part is communication. Communication part should be given with the VHF or any other equipments like VHFs, radar equipments, satellite communications, and in Marsat, EPUB should be used, mainly used in the case of emergency situations like drowning of ships, pirates attack. Yes. Now we are talking about classification of batteries. Batteries may be types of battery, mainly consumption with two types, chemical and phys- physical. Chemically we are using primary batteries, secondary batteries, and others. In primary batteries we are using lithium ion, nickel cobalt, lithium ion, carbonic zinc, and mercury oxide. In secondary batteries we are using mercury oxide and lead acid type. Lead acid type batteries and nickel cadmium. Nickel cadmium में others we are using fuel cells like hydrogen cells, and the batteries we are using physical energies from the environment like solar cell and thermonuclear energies for thermonuclear plants. A fuel cell. A fuel cell is an electrochemical cell, the reaction between two chemicals through electrochemical electrochemical process in the presence of a catalyst which is called S2SO4, or maybe some electrolyte should be used to transfer of electrons from anode to cathode through electrolysis process. Through this process we are obtaining a potential between the terminals of the battery. Yes, it is an electrochemical cell which convert chemical energy and electrical energy through electrochemical reaction of hydrogen fuel with oxygen and oxidizing agent. Working of fuel cell. If free electrons or other substance could travel through the electrolyte, they would disrupt the chemical reaction. Whether they combine at anode or cathode together, S2 or H2 form water which drain from the tanks and the cells. As long fuel cell is supplied with hydrogen and O2, it will generate electricity. Effect of conversion. Maybe problem will be arising during battery charging and discharging processes, maybe gassing up, mm, battery density, specific gravity density problems. Because of this problem will be happen. Condition of electrolyte, change in the plate volumes, generation of heat, loss of water. Gassing up mainly because of hydrogen evolved from the batteries. Hydrogen gas should be evolved during charging from the batteries. Maybe it is poisonous or toxic throughout the working environment, which affect the personnel in breathing, or maybe problem with the lungs and other things. Yes. Battery discharging condition and charging conditions. Lead acid battery, two types of lead are acted upon electrochemically by electrolytic solution of diluted sulfuric acid. Through the electrochemical process, anode and cathode should be in anode will be lead oxide and cathode will be lead sulfate. At cathode, we are taking back. At anode, lead oxide, and at anode we are using lead sulfate. This brown and spongy lead. Chemical action during the positive plate consists of lead peroxide and negative plate consists of spongy lead, which is lead, which is in brown color, or lead sulfate should be in gray color. Color should define the specific gravity of the electrolyte inside the plates. Basically, specific gravity should be in between 1.25 to 1.8. This is the normal range for the batteries to in working conditions and fully charged batteries. When lead acid battery is discharged, the electrolyte divide into H2 and SO4. The H2 will combine with some of the O2. This is formed on positive plate to produce water H2 and thereby reducing the amount of acid in electrolyte. Sulfate combined with lead of both plate forming lead sulfate. During discharging, both the plates are converted to lead sulfate, white in color. Sulfuric acid is consumed and forms water, which reduces the specific gravity of H2SO4 from 1.280 to 1.15. Terminal voltage per cell may be 1.8 to 2.1 volt. 1.8 volt to 2.1 volt is terminal voltage. Specific gravity may be vary from 2.8 volt to 2.1 volt. 1.28 to 1.15. Chemical energy is converted into electrical energy, which is delivered to the load. During discharge process, the sulfuric acid breaks into hydrogen ions and sulfate ions, which move freely in the electrolyte. At cathode, the reaction will be called PV, lead plus sulfate. PV plus SO4 gives lead sulfate, and at anode, lead oxide plus electrolyte H2SO4 plus hydrogen ions gives lead sulfate plus H2O. Battery equation: charge in charge condition, positive plate lead oxide plus electrolyte 2H2SO4 plus lead. This is reversible reaction. Lead sulfate plus 2 molecules of H2O plus lead sulfate, negative lead. Indication of fully charged cell. Gassing should be happen, or hydrogen ion should be released from a battery when battery should be in charge condition. The released hydrogen should be released from the cathode and O2 at anode. The process is called gassing. Voltage should be 2 volt to 2.1 volt when battery is fully charged condition. Specific density 1250 to 1280. And last one, color of plates. Positive plates should be in brown color at cathode and slate gray color should be in negative plates. So load test of batteries and method of measuring specific gravity and battery voltage. 12.6 volt given to that. 12.6 volt should be indicated the fully charged battery. Maybe battery should be in 100% charge. 12.4% volt indicate the 75% battery should be in 75% charge. 12.2 volt 50% charge, and 12.12 volts maybe 25% charge. Charge should be given to energize the battery. In case of any battery should be battery battery will de-energize, or maybe something happen with the batteries. So initial charge should be given maybe 24 volt. Equalizing charge, second one, equalizing charge will be given 29 to 30 volt. Third one, float charge or trickle charge to energize the battery instantly. 20 the voltage should be given either 26 to 27 volt. The boost charge 37 volts, and fast charge. Initial charge, float charge, equalizing charge, boost charge, and fast charge. Battery charging method. Constant voltage method should be used for the battery charging. Voltage is constant, but it results in very high charging current in the beginning. In constant charging voltage method, when back EMF the cell is low and low current, will the back EMF increases the battery. When the back EMF the cell is low and low current with their back EMF increases the in charge. Charge with this method, charging is almost reduced to half and increases the capacity of approximately 20%, but reduces the efficiency by 10%. By using constant voltage method, efficiency should be reduced for maybe 10%, and charging capacity should be increased by 2%. So that is all about batteries. We have learned, or just learning from the drives. Reading of batteries, cold cranking amps, the number of amps for the reserve capacity, the number of minutes the battery can deliver 25 amps while keeping its voltage above 10.5 volt. Reserve capacity, the number of minutes that battery can deliver 25 amps which keeping its voltage above 10.5 volt. Capacity or unit ampere per hour. Now battery questions maybe like unit of capacity, unit of charging, battery charging, first question. Second, types of batteries. Third, battery charging methods. Four questions. I throw battery charging questions. And applications of batteries on board ship. Yes. Okay, thank you very much. I said nothing else, my friend. I will cover up next video on the circuit breakers, safety fitted on the electrical installations, the circuit breakers and types of circuit breakers. Okay.